Okay, so 1122, what we need to do is to make compounds A and B using ethylene oxide. Oh, and that's nice, any alcohol we'd like. So let's start with A. There's the ethylene oxide and any alcohol. Now let me switch color. So looking at this, really what I'm seeing is that I am seeing my original epoxide here. Do you see this original epoxide there? Okay, so I need some sort of methoxy group, and that could be in the form of an alcohol, or I could always just, convert the alcohol to an alkoxide, and then I have another methyl group here, so I need some methanol. So with that strategy in mind, let's go like this. Let's take an epoxide, okay, and I'm going to attack it with methanol. I'm not going to give you any reaction mechanisms, okay, but here I'm going to end up with, this is what I end up with. Okay, so I've got my oxygen, and then the two CH2 groups, so I've got this bit in already. So comparing this one to the target molecule, let me just rub off these marks. Okay. Oh, no, not a good idea. Let me just draw out. So the target we wanted was actually this one. Is that right? Yeah, that's the target we wanted. And comparing this first intermediate with that one, we just need to convert the alcohol to this second ether group. Okay, so what I could do is I could convert that sodium hydroxide, okay, would convert it to an alkoxide, and then, yeah, I can attack, let's attack it with this bromide. And how can I get that? Well, I can use methanol, and then I can convert it to the bromide. Okay, so here's my second ether linkage, and there it is. Okay, there's my target. Okay, not target, target. Okay, so really the strategy is to see, I've got an epoxide, all right, I've got methanol, okay, when these combine, I form the first ether linkage. Okay, there's my first ether linkage, and really I also need to make, there's my first ether linkage, I need a second ether linkage. So I've got an alcohol at this end, so I basically do another ether formation at this side. And looking at it, I can even just use methanol, yeah, because two alcohols will also come together and form an ether. But in what I've talked about so far is using, yeah, an alkoxide, changing this to an alkoxide, an alkyl halide. So hopefully that explains it. The solution is written out in the answers, so here I'm just talking about strategy. Okay. What about B? B is interesting. B, let me go to another page. I'm going to run out of space. Okay, so I don't want those. No, I don't want those. Where are these coming from? Okay, let's get another page. So again, I'm using an epoxide and any alcohol I like, and what I'm trying to get to, or what we have to get to, is this very strange looking triple ether. But at the end of the day, they're just ether linkages. So we have already seen this one plus an alcohol. Okay, that opens up and gives me that first ether linkage, right? 1, 2, 1, 2, 3. Okay, so there's my ether linkage. Let's make this a methoxide. All right, so let's make this methanol. So now I have this hydroxy ether. Now when I examine this hydroxy ether, yeah, and I compare it to the target, what I'm focusing on, look at this symmetrical ether here, changing pen color. Okay, there's that central ether with two groups here. Okay, so what I really need to do is to have two of these, two equivalents of this one. Okay, and remember, when you have two alcohols coming together, that's another way of making an ether. All right, because what you have is one of them acts as the positive fragment and the other one acts as the negative fragment. So here what we have is, say, let's make this one, this fragment, okay, and then here what we'll have would be this fragment. So when you combine them together, okay, you're going to get actually exactly your target molecule. Okay, so there it is, methoxy with two CH2 groups. There's that new ether group that's formed, and on the other side, methoxy, carbon, carbon. Let me show you the mechanism because you'll probably want to see that, okay? So let me write out CH3O OH, alright, and then another CH3O OH. Okay, so in the presence of acid, one of them gets protonated. How would you know they're acid? Well, it says show a synthesis. Okay, so here it is. And then since this one is now a good leaving group, the other one is going to come in and attack. Okay, so there you are, the methoxy, two CH2 groups, that's gone. So there's the new bond that's formed. Yeah, 1, 2, 1, 2. Okay, sorry, there's the new bond that's formed. So there's my oxygen. So two more groups, and there's a positive charge there. So lose that proton, okay, and you get your target. Hopefully that helps. Let me pause to see how far we've got. Okay, let's look at this reaction then, and it's looking for a mechanism. Now this is not a mechanism you've seen, so it really tests your understanding of what kind of reaction mechanism steps are possible. We have an alcohol and we have this strange product. This molecule is dihydropyran, and I look at it and I go, okay, I have lone pairs here. It's clear that I've got a reaction at this spot. Okay, so chances are it's going to involve this double bond. Now this double bond attracts electrophiles. So what are electrophiles? It's going to be this one, isn't it? So the first thing that's going to happen would be that this electrophilic attack from the acid onto there. Now you've got a possibility when that, if you follow that through, you can either have the positive charge there, okay, or you can have the positive charge here. Now, a couple of things. I think it's going to be more stable in this second position. Okay, because you've got lone pairs here and that can resonate in. But more importantly, with this as a positive charge, look, I'm waiting for this group to come in. Okay, so I think we're going to go with this carbocation. So let's just delete that one for now. And now what you have your primary alcohol. Now this is open to a nucleophile, which is what an alcohol is. In it comes. So there you are. You've got now this protonated ether group here. And you know, some sort of base. I don't know what base is around, so I'm just going to use a B-. There it is. And there is your target. Hopefully that wasn't too challenging. Okay. Okay, and then 1525 wants a Wittig. Part A asks for this ketone here, and you want to convert it to this alkene. As you can see, what we're doing is converting, okay, let's go purple. We're converting this carbonyl group, carbon double bond oxygen, into this alkene. So what we're looking for then is we've got this ketone, and what we're looking for is this ylide. And so I need these two groups on it, which is a propyl group, a hydrogen, and what I'm really looking for is this ylide. Alright, and to get the ylide, Okay, let's do retrosynthesis. To get that ylid, what I'm looking for would be this alkyl halide, because moving forward, okay, so this is retrosynthesis. So what we're looking at is actually bromobutane. Watch what's going to happen to the bromide and the hydrogen with phosphine. The first thing that's going to happen is that, let me draw in the curly arrows. Okay, this acts as a nucleophile and kicks out your bromide. So what happens is that now you got a positive charge on this phosphorus. You treat it with N-butyl lithium, which is a very strong base. Let me curve it around here. Okay, and what that does is that it picks off N-butyl lithium, picks up one of these. So because it's actually the butyl group, it picks off one of these protons and that pushes it back onto that carbon, and now you still have one hydrogen left, but now this is a carbanion and this is still positive at this end. There's your ylid. Alright, so for this reaction, for this question, what I'm asking you to do, the skills you need is compare your starting alkene, starting carbonyl with your final alkene. Recognize that this fragment comes from the ketone and this fragment comes from the ylid. And to see the ylid, carbon with the hydrogen and then a propyl group, and the ylid will be negative on the carbon, and then the phosphine portion would be positively charged. Now, what I really need to see is not so much the ylid, but the alkyl halide that will go and give the ylid. And to do that, I simply need to convert this carbon, add another hydrogen and another bromide, because this hydrogen and this bromide are going to be lost when we move forward in going from the alkyl halide to the ylid. You see, in this first step, we've lost the bromide, okay, because the phosphine has substituted out the bromide, and in the second step, we lose that hydrogen. Okay, and hopefully that would be enough then. So we formed this ylid, and now with this ylid, all you need to do is treat it with the alkene they gave you, and that just goes beautifully to here, carbon, hydrogen. There's the double bond that's formed. There it is. Okay, right. Now that I've done that, let me pause because somebody wants to talk to me. Okay, let's do this one quickly then. So this time what I have is, I'm going to write this way so you can see it. And in order to convert it to this new alkene, you see I've got an extra carbon here. Alright, so there's my carbonyl portion. So this has come from the ylid, okay, and the ylid has got to come from the alkyl halide. Alright, so what's the ylid? The ylid has to have these two groups on it, okay, but it's negative this end, and the triphenyl phosphine positive that end. That's the ylid, and to go backwards from the ylid to the alkyl halide, I still need these two hydrogens there, but there's that hydrogen that's going to be removed when we make the ylid, and there's that one, okay? So, let's go forward then. Okay, methyl bromide, okay, treat it with triphenyl phosphine, and that loses my bromide, and it replaces it with the phosphine part. Treat it with N-butyl lithium, and that strips off one of these hydrogens and makes this negative here, but I still have my positive charge, so there's my ylid. And so the ylid is the one that then combines with this carbonyl, okay, and what that does is swap out this carbon double bond O and make it a carbon double bond C, and what's on this alkene carbon here then is these two hydrogens, okay, which is your target. Hopefully that was quick. With this one I'm going to go really quickly now, alright? So now there's my carbonyl peak, so there's my carbonyl, okay, and that's my ylid. So very quickly then, what's my ylide? I'm just going to do it like this, okay? So here, what do we have here? We have carbon, okay? Needs to be negative, and here, there's the positive. Look, there's a hydrogen there they haven't drawn, so there's the hydrogen. Alright, so that is the ylide. So going backwards, what do I need? I need the benzene ring with its 2 ethoxide. So this is the interesting carbon. It needs that hydrogen because it's got the hydrogen and the aromatic ring. Another hydrogen which we can strip off, and this one. Alright, so this ketone and this alkyl halide, which then becomes the ylide, will give you a wittig. Okay, hopefully that helps. I'll stop there.